Hello teacher, I'm Sherzodbek and today I'm gonna explain my assignment 2 from our course Artificial Intelligence. Okay, let's move on. And for our assignment second, we had the two type of our tasks. So it was first of all was bias network. So we're gonna start with bias network. So bias network is about modeling how genes and inheritance and how they affect how the people's inheritance and genes gonna affect our traits. For example, some people had a problem with the hearing, and how my this problem gonna affect my son or some or my daughter, and our AI model's gonna help us to calculate this type of genes, traits, yeah, for the future, for by using Bayesian network. So, okay, so I made it with pie charts first of all, and so for example, each person has a gens, yeah. For example, 0, 1, or 2, the type of gens, and the trait variable. So whether they show a trait true false based on the gens, yeah, it's a traits, it's a gens. So and the variable, whether they show a trait. I mean the bias network in quotes, something about like that, and. So actually, how it will affect to our future generation, we're gonna see it now. So we're gonna use our data set. For example, here I had the three type of data sets: family 0, family 1, and family 2. So how parent genes gonna affect our child's, and the person's genes gonna affect per person's trait. So I already explained what is trait. So we use this to calculate the probabilities of genes and traits in a family. So our main class, which is calculate the probability of having the mutation. Yeah, there is also mutation. It's a probe. There is a probe class. Let me find it first of all. And yeah, this is probe class. There is, for example, gens, true, false, and traits and mutations. Uh, so probability of person having 0, 1, or 2 copies without knowing parents, and the probability of showing the trait of depending the number of genes and copies. And the mutation is um, here was a mutation. Yeah, mutation is a chance gen changes during the inheritance. So the second main class was joint probabilities. This is our second main class, and how people join probability. I mean, one gen set of people with one copy, two gens set of people with two copies, and have a trait set of people who show the trait. And the algorithm is working like that. For each person, if no parents, there is probe. If no parents, use the probes. If people has a parents, we're gonna say it like something like that. Calculate the probability based on parents gens and mutation, and multiply with the trait probability probes trait, and something like that. This gives a probability of exact combination of gens and etc. And update probabilities. Yeah, update probabilities is p probability for each person. Probability dictionary. Probabilities accumulate over all possible combinations. And so actually, let me show you what did I had when I ran. Actually, I had a three type of dataset, and I ran all of them. I used all of them. So by Python, heredit.py, that family.csv, and Harry had a second, I mean, mutation, and the probability of having trait is 0.0092, and trait true and false, and most of us he will not have a same kind of trait. So for Harry, for James, for Lily, I had this type of output if you're gonna look for that. And for next dataset, family one dataset, I had a Charlie, Arthur, and Fred, and yeah, you can look for my outputs. And there was Ginny, Molly, and Ron from Harry Potter. Yeah. And for third dataset, I use family 2. And here is also Arthur, Hermione, Molly, yeah. And you can look for my outputs. and something like that. So task one, I mean, our first task was about the models gen inherited using the Bayesian network. So each person has a gen variable and trait variable. Probabilities of gens and traits are calculated using known probabilities, potential inheritance, and mutation. The joint probability function considers all the possible combination and updates probability. And finally, normalization. I had a normalization here. Yeah, this normalization is ensures the probabilities sum to one. So it was my first task, and let's move for our second task, and it was about the flight cancellation prediction using knowledge-based agents and uncertainty. So it's actually it wasn't like hard how to say task. So okay, so for first of all, in to make us this task, we had to use uh, GPT notebook, and they use two type of AI. It's a knowledge-based agent and uncertainty. So what is knowledge-based agent? It's a type of agent AI, so which is going to use only facts, you know. So it doesn't rely on some random things, or using only the facts and using facts and logic, and stores knowledge in the form of rules, and makes decision based on the facts and logic, you know. And instead of learning ML, it's reasoning using the rules. So first of all, we created logical rules, and we had our sample data, flight sample data, and by looking at that, our AI gonna predict that is it am I gonna cancel the flight or no? And depends on the delay of the weathers, you know. So okay, let's move on. For example, for in task two, for task one, knowledge-based agent, we're gonna put the logical inference. For example, if because of the weather our flight gonna delay for 60 minutes, it means we're gonna cancel the duration. If our flight gonna be delayed for 90 minutes, we're gonna cancel the deletion, and it'll be same as for 2 hours, 120 minutes. And it sounds like that. So we inputted a knowledge-based agent in our case. So a second for task two, probability and bias. So we used bias here um, for like uh, we already said that if we're gonna delay for 60, 90 minutes, we're gonna cancel the hour flight, you know. And but second was now we're gonna move for uncertainty. So not actually all the flights gonna be canceled for because of the weather, you know. So in this case, we're gonna need the probability, and we're gonna use the probability and calculating the probability by the so what percentage of flights are canceled, you know. So we're gonna our variables, and using the our percentage, the meaning, you know, and something like that. And for third step, we had a hybrid AI prediction. It's like both of them, like both probability bias and knowledge-based agent is concluded, and making the decision by giving the if-else statements. Okay, and for last one, for example, we had a scenario, you know. For example, the delay was because of the days there was 18 minutes, and the delay because of the carrier was 10 minutes. So, and what gonna happen in the end? So our AI gonna predict about that. So prediction output was our flight was cancelled. So because it showed one and not cancelled. So one, it means our flight was cancelled. So I hope I think it was understandable, teacher. So thank you for watching my task. So hope I'll see you in the class. See you.